All right, our goal here on F5A, so F5 we're breaking it into a couple parts. So our goal for F5A is to use linear functions to model situations. And here's what here's what I mean by that, and it sounds bigger than what it really is. So here we know that linear functions are in the form of f of x equals mx plus b, and we're used to that, right? We have our y-intercept and our slope. Well, here with our y-intercept, when we're modeling situations, the y-intercept is going to be what's called the initial value. Another way of looking at that might be the starting value, right? Whatever the value is whenever x equals 0. And then for m, right, this is our slope. And remember, slope is going to be some sort of a fraction, right? Well, here we think of this as rate of change. And rate, like the best rate I know is miles per hour, right? You drive down the freeway at 75 miles per hour and you go 2 hours, you've driven 150 miles, right? That you know. So when I think of rate, I think of miles per hour, miles per hour. Now look, we said slope was a fraction, and look here I have miles divided by hours, right? This is a fraction. And note here, this division symbol here is per. So one way of thinking about dissecting this is whenever you see a rate, we know that something happens in something per something else, okay? And really, the best is our output. When it comes to our inputs and outputs, whenever we're dealing with real situations, the input is something in general that you have control over, right? And the input in this situation is going to be our independent variable, and our output will be the dependent, because the output dependent variable. All right, so let's put this in action. These are the notes that you should have. Okay, so Bennett, whoever this guy is, and his friends decide to go bowling. The cost for the whole group is $15 for shoe rentals, plus $4 per game. Look at that, per. So what do you bet that this is going to be our rate, right? All right, so how much will it cost them to bowl 2 games? And let's show our work. Well, when they first walk in, they have to pay $15 for shoes, right? So 15 for shoes, and then $4 per game. Games, the cost of shoes, the cost of the games, gives us 15 plus 8, which is 23. So it's going to cost $23. It'll cost us $23 in order to play 2 games. All right, well now it asks us to write an equation relating the total cost C of the outing to the number of games bowled G. All right, so this is where we need to define our X and Y. Well, here, the total cost. How much is this going to really cost us? So our cost in terms of number of games is, what's that rate? How much per game? Well, we saw earlier it was $4 per game, plus if we didn't bowl any games, it would cost us $15 just to rent shoes. So 14G plus 15. Now this is our model, right? So the independent variable again is X, the dependent variable Y is going to be cost. All right, now it wants us to 15, 20, 25, and let's see if that works. Can I really go up for 1, 2, 3, 4 and over 1? Does that make 2 games? It was going to cost us $23. So we'd be somewhere in here. I'm going to be a little bit more exact though. If I bowl 5 games, well, let's see, 4 times 5 plus 15, that'd be 20 plus 15, well that's 35, and that would be way off. Oh shoot. Well, I should probably reorganize this. So instead of doing that 5, 10, and 15, alright, make some mistakes and you're allowed to. Let's go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, so here at 5, 10, when it's 5 games, right, so $35. So 5 games, where's my 35? Right there, boom. Now, I have 2 really solid points, and I can graph. And here we're gonna graph on through. Notice I didn't go to the left. Can you play negative games? Well, of course not. So here my graph starts here at 15, goes on forever. You could play games, I suppose. All right, and the last question is, use the graph to estimate the number of games. I'm gonna underline this word, estimate. No, this is a cost, right? So I'm gonna go to my cost side here at $30 and 3 games. Okay? As you go through about how do we think about independent variable versus dependent variable, how do we build this function in the form of mx plus b, mx plus b, mx plus b, right? And what is the meaning of slope? What's the meaning of our slope here? Well, our slope was 4. The meaning of slope was the cost per game. And the meaning of our y-intercept, the meaning of the y-intercept is the